The distributed type pump uses a vane type transfer pump to fill the single pumping element. This then raises fuel pressure to injection pressure. A distribution system then distributes fuel to each cylinder in the firing order of the engine. The most common type in light automotive use is the Bosch VE pump. A drive shaft driven from the engine rotates a plunger and a cam disc. Cams on the face of the disc have as many lobes as cylinders in the engine. A plunger spring holds the cam disc against rollers that rotate on their shafts. The lobes move the plunger to and fro in its barrel, making it rotate and reciprocate at the same time. Its rotation operates the fuel inlet port to the pumping chamber, and at the same time distributes pressurized fuel to the correct injector. The reciprocating motion pressurizes the fuel in the pumping chamber. The plunger's pumping action forces fuel through a delivery valve to the injector. This pump is for a 3-cylinder engine, so it has 3 delivery valves. The barrel has 1 intake port and 3 distribution ports. The plunger has a central passage, a connecting passage to the distributing slit, and a cross drilling to a control sleeve. As the plunger rotates, each intake slit aligns with the intake port, and the distributing slit with the distributing port. As the plunger rotates, the intake slit moves away from the intake port. At the same time, the plunger is acted on by the cams, causing it to move axially along the barrel, pressurizing the fuel in the pumping chamber. The distributing slit now uncovers the distribution port, and the pressurized fuel passes through the delivery valve to the injector. Further rotation of the plunger closes off the distribution port and opens the intake port. At the same time, the plunger spring moves the plunger back along the barrel for the next pumping stroke. For intake, fuel from the feed pump reaches the open intake port in the barrel. The intake slit aligns with the intake port, and fuel fills the pumping chamber and passages in the plunger. For injection, the plunger rotates to close off the intake port and moves along the barrel to pressurize fuel in the pumping chamber. The distributing slit aligns with the distribution port, and the pressurized fuel forces the delivery valve off its seat and reaches the injector. In this phase, a cut-off port in the plunger is covered by the control sleeve. To end fuel delivery, the plunger's cut-off port moves out of the control sleeve and lets pressurized fuel spill back into the pump housing. This relieves pressure in the pumping chamber, the delivery valve closes, and injection ceases. Metering the fuel is controlled by effective stroke of the control sleeve, and that's determined by the action of the governor sliding the control sleeve along the plunger. Sliding it one way opens the cut-off port earlier and reduces effective stroke. Sliding it this way delays its opening and increases effective stroke. The governor changes the position of the control sleeve to vary the quantity of fuel delivered according to throttle position and load. When the ignition is switched off, an electrical solenoid closes off the intake port and stops fuel delivery.